Okay, see, quite a few people looking around like they have these done. So let's take a look at these. This first one up here, what are we going to do? We're going to divide it by -8. That'll leave us with x. We've got to divide this by -8. 56 divided by -8 is -7. Good. So x equals -7. Now this next one, x minus 12 equals -4. Add 12. So over here we just have x. Over here, -4 plus 12 is 8. Again, think of the number lines. -4, positive 12 is the other direction and longer. So it's positive. The difference between 12 and 4 is 8. So x equals 8. This next one, what do we have to do? Add 13 to get rid of the -13. So x equals, what is -19 plus 13? Is a -6. Very good. How many of you are starting to get a little bit more comfortable with the negatives? How many of you still feel very, very confused about the negatives? Okay, well, that's not bad. Usually at this point, there's 3 or 4 people that really can't stand the negatives. So this next one, what do we have to do? Multiply by 5. Very good. It's giving us x equals, what's -14 times 5? -70. Now this next one, I added that one at the end there. It's one I really wanted to make sure we look at, because we have 19 minus x equals 34. And if we break this down, we find the equal sign, and here's the side with the variable on it. What's keeping the x from being alone is the 19. And when we ask what operation is used to attach the 19, it's very easy to say subtraction. But the 19 is not subtracted from the x. The x is subtracted from the 19. Well, we can't deal with it that way. There's no way to, unless I suppose we could add x to both sides and it would move over to the other side, but that gets to be pretty tedious. The way we handle this, whenever we have a subtraction or a minus in front of a variable with nothing else there, we treat it as though it is a -1 times that variable. So this is 19 and -1x. Remember, subtraction, when we're dealing with negatives, can be thought of as plus a negative. So here what we have, since this is a positive 19, the 19 was added to the -1x. So to get rid of it, we're going to subtract 19. So what's left here is the -1 or -1x equals 34 minus 19 is 15. Now what do we need to do? Divide by a -1, leaving us x equals a -15. So that one's kind of tricky. Any questions or any of those that you want me to go back and go over again? Or do another example of any of those? Let's do another one similar to that last one. Go ahead and try this one quick, and we'll go over it in a minute. So looking at this, where are we going to start? We're going to subtract 17 because it's a positive 17. Remember, we're going to think of this as a -1y. So after we subtract 17, 13 minus 17 is -4. What's left on this side? -1y. The 17 is gone. Now what? Divide by -1. So 4 equals y. Any questions? Okay. Now, just a little bit of warning. I meant to bring this up last Thursday, but I don't remember if I did or not. We are finishing up Unit 1 today, which means this coming Thursday is our Unit 1 test. On your Unit 1 test, on any test, you are allowed to use your books and your notes. The test is paper and pencil in class, just so you know. So it's not on the computer, it's in class. For those of you in New Richmond, when you get to class, somebody from the ITV office will have the tests available in the room somewhere for you. When you're done with them, you just turn them back into the ITV office and they will scan and email them to me to be graded. Then we'll get them back to you. Okay, well, let's get on to our new material so we can finish up Unit 1, and then hopefully I plan on spending most of the second hour to review for the test. When we talked about order of operations, we saw this symbol or this type of notation a few times. What does that mean? 7 squared. And how would we calculate it if we didn't have a calculator? Yeah, 7 times 7, which is 49. How about that? Okay, some call it 8 cubed is one way of saying it, or 8 to the 3rd power. And how would we calculate that? Perfect. 8 times 8 times 8, or 3 eighths multiplied together, or 512. Now, if you didn't want to calculate those in your head or write them out on paper, do you guys know how to do that on your calculator? Depending on your calculator, you have 1 or 2 buttons. If you have a graphing calculator, you'll have this button, or most of the TI-30s have this button. Looks like that. It's called the caret key. Some of your Sharps, Casios, and some of your older model TI-30s have an X to the Y key. To use that key, you just, like for 8 to the 3rd power would be 8. You'd press whichever key you have and type in the 3 and hit equals. Should give you 512. Let's test and see if we're getting it to work. How about we do 3 to the 5th power? You get 243. Perfect. I'll race you on this one. 5 to the 6th power? 15,625. Very good. Is there anybody that didn't get their calculator to work right with the powers? That needs me to help them find the right key? Everybody's got it? Perfect. Well, we've been talking about these integers a little bit last class, and we had them in our equations that we were solving here earlier. When I multiply a negative times a negative, what do I get? A positive. So negative 7 times negative 4 will be 28, or positive 28. If I have a positive times a negative, I get a negative. So 5 times negative 9 will be negative 45. So without using the calculator, let's take a look at some things here. Negative 5 squared, of course, would be negative 5 times negative 5, which should be positive, what's 25? Good. Negative 8 squared should be negative 8 times negative 8, which should be positive 64. Good. Negative 4 squared should be negative 4 times the negative 4, which should be positive 16. Anybody see a pattern developing here? Well, when we square a number, the answer is always positive. Even though this is a negative 4, when we square it, it is always positive, because 2 negatives multiply to make a positive. So I want you to try to punch this into your calculator. Negative 5 squared. And see what you come up with. Anybody's calculator spit out negative 25?
Yeah.
A few of you did. We know that's wrong because we know it has to be a positive 25. Well, you'll notice when I write it in parentheses. When you enter it in your calculator, you must also put the parentheses around it. Some of your calculators will do it correctly without. Most of them need the parentheses. Because order of operations says the power, the exponent, happens before the negative. So it squares the 5 to get 25, then puts the negative on it. So try it, making sure you know how to use your parentheses to make sure that comes out to be a positive 25. So now let's try this one. Negative 7 to the power of 3, what do you get? Perfect. Negative 343. What if I have a negative 4 to the power of 4? $256. Very good. And it's positive. Negative 3 to the power of 5. Negative 243. Negative 5 to the power of 6. 15,625. And we'll do one more. Negative 2 to the power of 7. Negative 128. As we look at these numbers here, these results, is there a pattern that we start to notice there at all? Yeah, what do we notice? Okay, the odd powers, we get negative answers. The even powers are always positive. Let's look at that. If we were to calculate one of these out by hand, negative 7 to the third power is negative 7 times negative 7 times negative 7. Well, negative 7 times negative 7 is a positive 49. Times a negative 7, well, now it's a positive times a negative, so it has to be a negative 343. But for the negative 4, the power of 50, or to the power of 4, that's 4 negative 4s multiplied together. Well, negative 4 times negative 4 is a positive 16. Times another negative 4 is a negative 64. And now it's a negative times a negative makes that a positive 256. So anytime we have an even power on a number, the result has to be positive. If we have an odd power, however, the result can be either positive or negative. Be careful. Don't start saying that if it's an odd power, the answer has to be negative, because we can still have that. That's an odd power, but it's obviously going to be positive because 6 is positive. 6 to the third power is 216. Now, when we look at our operations that we've talked about, every operation we have seen comes in pairs. We talked about addition and subtraction being the same operation. And they are. And what we saw with the negatives is you turn subtraction into addition. That subtraction is just a shortcut for certain types of addition. They're also what we call inverses. Inverses are operations that reverse or undo each other. They eliminate each other. For example, somebody pick a number for me between 1 and 10. 9. Okay. Somebody pick another number. You had one in Richmond. What was your number? 10. Okay. 9 plus 10 is 19. If we want to reverse that, if we want to get from 19 back to the 9, what are we going to do? Subtract the 10. Gets us back to 9. Adding 10 and subtracting 10 reverse each other. They cancel out. That's what inverses do, is they undo each other. They reverse each other. Addition and subtraction are inverses. If I add a number and then I subtract that same number, I get right back to where I started. If I have 12 plus 7, I'm going to get 19. Well, if I go 19 minus 7, I am back to 12. Likewise, if I started with subtraction. If I have 11 minus 3, I'm at 8. If I take 8 and add the 3 back to it, I'm back up to 11. I get back to where I started. Well, multiplication and division are also inverses. We talked about them being the same operation, or division and with our fractions is going to become multiplying by reciprocal and stuff like that. So once again, they're inverses. Let's take our 9 that you guys chose and 10. 9 times 10 is 90. If I wanted to get from that 90 back to the 10, I would have to, or sorry, from the 90 back to the 9, I have to divide by 10. Gets me back to 9. Multiplying by 10 and then dividing by 10 reverse each other. It takes us right back to where we started. And the other is true as well. If I had 24 and I divide by 8, it gives me 3. If I want to get from that 3 back to the 24, it's 3 times 8 takes me back to the 24. Dividing by 8 and multiplying by 8 reverse each other. They're inverses. They cancel each other out. So now we've just learned this new operation, the power. 7 to the power of 2, or 7 squared, is 49. There is an inverse for it. It's that, the square root. The square root of 49 is 7, because 7 squared is 49. And squared and square root reverse each other. There's a slight problem with that, though. What's negative 7 squared? Positive 49. Negative times negative is a positive. So then, according to that, the square root of 49 has to be negative 7. So which one is it? It's both. There are two answers. When we do a square root, there will always be two answers, one positive and one negative, because a negative number squared is also going to give us a positive result. So we have to be careful with that. The square root of 25, most of us probably know off the top of our head that that is 5. But it could also be negative 5. So we have to be very careful with it. We said that 7 to the power of 3 is 243. That square root, it's actually called the radical symbol, but we often refer to it as just the square root symbol. With that little 3 up there, means that this is not a square root, it is a third root, or a cubic root, which means we're trying to reverse a power of 3. So the cubed root of, or the third root of 243 is 7, because 7 to the third power is 243. Do I have to include or negative 7 here? No. Because if it were a negative number, it would come out to be a negative answer. The third root of a negative 243 is negative 7, because negative 7 to the third power would be a negative 243. So now with that in mind, what would be the square root of a negative 64? If you know this, stay quiet for just a second. If you were to punch that in your calculator, what's it going to do to you? Most of your calculators, you have to hit the square root key first and then type in the negative 64. And on many of your calculators, you have to do shift or second to get to the square root key. And then type in the negative 64. Some of you, if you have an older model of a TI-30, you might have to type in the negative 64 first and then hit the square root key. What's it tell you either way? Gives you some sort of an error, doesn't it? Calculator doesn't like that. Why is that? Because this can't be done. Remember, the square root, if I give an answer for that, I'm saying whatever that answer is, if I square it, it has to give me a negative 64. But when I square something, I always get a positive answer. There's nothing I can square that will give me a negative number. So there's no way to do a square root of a negative number because there's nothing for it to reverse. We will talk about roots more later in the course when we start looking at geometry and right triangles and all that fun stuff. Okay, so we looked at some of our negatives earlier. Yeah, I know, you're thinking fun, really? I'm a math geek. That means I'm not totally sane. So anyway, let's look at order of operations. You might have like a negative 12 minus 7 times negative 8 times 4 minus 3 times negative 5 plus 2 plus 7. We've done order of operation problems before, but when we start putting the negatives within them, it gets more complicated because now the parentheses are not always an enclosing symbol. Sometimes they're just there to isolate the negative with a number. And that occurs in this problem here. We find, first of all, our first set of parentheses right here, and its other end is down here after the 2. So we're starting out inside that parentheses, inside the yellow box. Well, inside there we have another parentheses right here. But as we look at it, it's already down to just a single number in there. There's nothing to do there. It is not an enclosing symbol. All it is doing is saying that is a negative 5 times that 3, not 3 minus 5. So we're back out to working in the bigger parentheses, the yellow box. What are we going to do first there? Perfect. Negative 8 times 4. Everybody wants to be drawn here because of the parentheses. But that is just multiplication, and it happens left to right with all the other multiplication and division. So negative 8 times 4 is negative 32. Now for the next step, of course, it is this negative 5 and the 3 or negative 3, however we're going to look at it. So a lot of people will ask, is it negative 3 times negative 5, or is it just 3 times a negative 5? The answer is yes. I know that's not what you wanted to hear, but you can think of it either way, whichever way is easier for you to think of it. We could think of that as just minus a 3 times 5. So that means our result would be negative 32 minus 3 times 5 is a negative 15 plus 2. We could think of it that way and it works just fine. If we wanted to think of it as being a negative 3, however, we would have to change it to be plus a negative 3, like that. Now it's a negative 3 times a negative 5, which is a positive 15, plus a positive 15. Well, what's going to happen here anyway? Minus a negative 15 is going to become plus a positive. We get to the exact same result either way. So when you ask me, do I think of that as being subtracting 3, and the 3 is multiplied by negative 5? Or do I think of that as being a negative 3 times a negative 5? Whichever way is simpler for you to think about it and work with it. I usually leave it as subtraction as long as I can, and then I change it later. But either way, we're going to end up at this stage at some point. Now we're still inside the parentheses. Any more multiplication or division? No. So next is addition and subtraction, left to right. Where do we start? Negative 32 plus 15 is negative 17. And then plus 2 would make that negative 15. Now again, this parentheses is down to a single number, so I don't need them there. But I can't take them out. Can anybody tell me why? That's a negative 15 in there. I need to keep those parentheses there to show that that is a negative 15 and not minus 15. But I'm going to put in the multiplication. And once again, we're with that dilemma. Is this really 7 times negative 15? Or negative 7 times negative 15? I'll let you guys, I'll take a poll. Which one works better for you guys? Negative 7 times negative 15? So we would have to change this to be plus a negative 7. So now this is a plus up here. This is negative 12 plus. Negative 7 times negative 15 is a positive 105. Negative times the negative is positive. 7 times 15 is 105. So now negative 12 and 105 make 93 plus 7 is 100. Any questions? How many feel like you could do one of those on your own? See what you come up with for this one. Try this in your note. You ready or you need more time? Ready? Okay. On top, what do we do first? Negative 8 times 7, which will be negative 56. Now over here, you guys prefer to look at this as plus a negative 6. So it's negative 6 times negative 3. Positive 18. So it's either going to be plus 18 or minus a negative 18, which becomes plus a positive 18 anyway. So you have negative 56 plus 18. Negative 38 is what we get on top. Very good. On bottom, what do we do? Negative 5 times negative 6 is 30 plus 4 times negative 7 is a negative 28. And then 30 plus negative 28 is a positive 2. Very good. So we got 2 here. So then what? Negative 38 divided by 2 is negative 19. How many got negative 19? Good deal. How many of you want to see one more example? Couple? Okay. One more. Okay, do this one quick. Negative 120, and I hear a 110. Let's see which way we went. Inside here, we've got the 3 times 8. Do you want to treat that as 3 times 8 or negative 3 times 8? Because it really doesn't matter. If it's negative 3 times 8, we're going to make this plus a negative 3. So negative 3 times 8 would be negative 24. So now inside the parentheses, we still have to do 7 plus negative 24, which is negative 17. Positive 7, negative 24. Looks like that. So now negative 9 minus 7. So now we're going to want to change that to plus a negative 7. So it's negative 7 times negative 17, which is 119. And now it's a negative 9 and a positive 119, which is 110. Well, our next step is actually going to build off of this. We're not going to actually just do direct order of operations, but we're going to see things that look like this. Now we look at that. Right now there's absolutely nothing we can do there because we don't know what those letters B, D, M, and X stand for. But if I tell you that B equals 4, and M equals 2, and D equals 7, and X equals 3, now we can go about solving or evaluating this. The command we would give would generally be evaluate to get a value for this. And what we have to do is we have to replace each of those letters with the number it represents. So 7x. Now, before we put the number in for x, we got to think, what operation is really being represented here? Multiplication. Good. It is 7 times x. So then when you put in the number, this is going to be 7 times, what's x equal? 3. So 7 times 3. Minus, d is going to be 7. 5m becomes 5 times 2 minus b squared becomes 4 squared. And now we can go ahead and do our calculations. We're going to start inside the parentheses. 4 squared is 16. What's next? 5 times 2 is 10. And then 10 minus 16 is negative 6. And then? Well, it was subtracting 16 or plus a negative 16. But either way, it will come out to be a negative 6 will be our result. And now, if you seems like you guys want to treat this as a plus negative 7. So negative 7 times negative 6 is... Actually, can I do that yet? No, I need to do 7 times 3 is 21. I almost screwed that one up. And now it'll be the negative 7 times negative 6, which makes 42. It's a positive 42. Gives us 63. So any questions on that? Okay, here, let's do... So looking at something like this, if we let D equal 5, M equals 8, T equals 2, and P equals 4. I'm going to give you guys Try to evaluate that. Give me the value for that, and we'll come back and check it in a minute. Correct that real quick. Hopefully that didn't mess you up too bad. Sorry about that. I realized that after I looked at it again, I forgot to put the negatives. Let's take a look and see where we're at here. So let's plug the numbers in. This is going to become 5 times 8 is where m is, minus 2 times, now the negative 4 squared, we've got to put that in parentheses so we know the negative 4 is squared, not just the 4, plus 22 divided by negative 2 over 2 times 5. Now what? Negative 4 squared is 16, positive 16. And then 22 divided by negative 2 is negative 11. And then 16 plus negative 11 is a 5. So we have 5 times 8 minus 2 times 5. I can get rid of the parentheses since that's positive. I don't need to isolate the negative anymore. Now what? 5 times 8 is 40. 2 times 5 is 10. So we have 40 minus 10 is 30. So the top of this becomes 30. The bottom's pretty simple. 2 times 5 is 10. Are we all done? No, we still have to do 30 divided by 10 is 3. What do you guys think? Still better than a sharp stick in the eye? For now. Okay, this is a good time to take our break, so let's go do that. It's about 4:21 right now. Let's start lecturing at 4:31.